Hello. The title of my experiment is The Effect of Probiotics on the Growth and Height of Lima Bean Plants. There is an estimated 2 billion overweight individuals within the world, and of those 2 billion people, nearly 650 million people are considered obese. This large number of overweight individuals proves that the health of the human race is on a steady decline, and soon, the average lifespan of humans will become lesser and lesser. With this in mind, I've concluded that something needs to be done to halt these rising obesity rates, and I yearn to help the world return to a position of health and longevity. That is where super plants come in. Probiotics are vital to human life, as they are responsible for balancing out the harmful bacteria and the good bacteria within the digestive tract. Probiotics are especially notable for their ability to destroy disease-causing cells, aid in the body's vitamin production, and treat diarrhea, eczema, lung infections, and gastrointestinal infections. Because of probiotics' bacteria-fighting abilities, I wonder if they could have a similar, if not better, effect on plants and their growth. Therefore, the question of my experiment is, how does the type of probiotic affect the growth and height of lima bean plants? For this experiment, the 3 probiotics I used were Lactobacillus acidophilus, Saccharomyces boulardii, and Bifidobacterium longum. The control group was watered solely with water. When watered with these probiotics, the plants could experience profound growth, as the probiotics will help maintain the plant's cellular processes by balancing the beneficial and harmful bacteria within the plant's microbiota. These energy-endowing plants could potentially improve the growth, health, and development of everyone who eats them, also improving the human lifespan and overall quality of life. The world's unhealthy inclination towards fast food is often due to limited grocery stores, increased fast food restaurants, or high-priced organic goods. So hopefully, these bioengineered plants will serve as a more nutritious alternative to the goods currently sold in grocery stores, while also being in a more affordable alternative to the expensive fruits and vegetables that currently consume grocery stores. Thus, I want these plants to be easily available and accessible to everyone, no matter the country nor continent. Unhealthiness has proved to be a huge problem for not only Americans, but people around the world. Thus, I hope these plants not only improve eating habits, but improve our overall health by supplying the necessary nutrients and probiotics. In regard to the experiment, I decided to use lima bean plants because they sprout quickly, averaging only 4 days, and their heights are easy to measure when the experiment has concluded. Furthermore, lima bean plants can be grown in the house, making them perfect for my indoor experiment. This slide mentions my question, hypothesis, and materials. I hypothesized that if the lima bean plants are watered with Bifidobacterium longum dissolved in water, then they will grow the most in height over the course of 28 days when compared to the plants watered with dissolved Lactobacillus acidophilus, dissolved Saccharomyces boulardii, and the plants watered solely with water. The materials are also listed in detail for you to see. As for the procedure of my experiment, I first started off by filling the planting cups 3/4 full with soil. I then placed 1 lima bean seed 1.5 inches deep in the soil. After that, I divided the cups in groups of 3 and labeled each group with a different liquid, either dissolved Lactobacillus acidophilus, dissolved Bifidobacterium longum, dissolved Saccharomyces boulardii, or just plain water. I then watered each group with their respective liquid using steps 4 through 16, and I did so every other day. And I let the plants grow for 28 days before taking their final measurements. I did so with a ruler, and I recorded these final measurements in a data table and bar graph. This is a photo of when I first planted the lima bean plants. This is a photo of the plants nearly a week later. So at this point, we notice that none of the plants in the water group has sprouted. We notice that 1 out of 3 of the plants in the lactobacillus group has sprouted. We notice that all 3 of the plants in the bifidobacterium group has sprouted. And we notice that only 1 out of 3 of the plants in the lactobacillus group has sprouted. Fast forwarding a week, we see that a lot of development has happened with these plants. The plants in the Lactobacillus group, Bifidobacterium group, and Saccharomyces group look really strong and healthy. Contrastingly, the one plant that has sprouted in a water group is looking small compared to the other plants and is slightly discolored. At day 22 of this experiment, this is how the plants are looking. As we can see, one plant in the water group has continued not to grow, while the other two have grown, but they are fairly small compared to the other plants. Similarly, two plants in the Saccharomyces group have either limited growth or no growth at all, while the third plant in this plant group definitely is experiencing profound growth and looks extremely healthy and strong. The plants in the Bifidobacterium group also appear to be thriving. As for the Lactobacillus group, one plant is doing extremely well as it is pretty tall in height, while one plant has not grown at all, and the last plant in that group is experiencing pretty lackluster growth. This is how the plants looked on day 28, the last day of the experiment. So as you can tell, one plant in the Bifidobacterium group, it was damaged, so I had to estimate how tall this plant would be at day 28. While the other two plants in the Bifidobacterium group do look very healthy, one plant is taller than the other, but they both look extremely green and unblemished. Regarding the plants in the Lactobacillus group, one plant experienced profound growth, while the other two plants experienced rather lackluster growth. One of the plants in this Lactobacillus group didn't sprout at all, while one experienced no more than a couple centimeters of growth. As for the water group, two of the plants did look extremely healthy, but they did experience less growth than the other probiotic groups. And then that third plant in the water group did not sprout at all. As for the Saccharomyces group, one plant did experience profound growth, much like the Lactobacillus group, but two of the plants experienced lackluster growth. One did not sprout at all, and one experienced no more than a couple centimeters of growth. At the end of 28 days, here are the results. The plants watered solely with water grew an average of 11 centimeters. The plants watered with dissolved Bifidobacterium longum grew an average of 54 centimeters. The plants watered with dissolved Lactobacillus acidophilus grew an average of 28 centimeters. And the plants watered with dissolved Saccharomyces boulardii grew an average of 26 centimeters. This data is further demonstrated using this bar graph. Over the course of 28 days, the plants watered with dissolved Bifidobacterium longum grew the most in height, averaging 54 centimeters. Although the other probiotic groups weren't too far behind, it is evident that the plants watered solely with water experienced slower growth than the plants watered with the added probiotics. The drastic contrast in results makes it clear that the probiotics best stimulated the growth of the Lima bean plants. Since the addition of Bifidobacterium longum did cause the Lima bean plants increased growth in height, my hypothesis was thereby supported by this experiment. Thus, it can be concluded that probiotics have a similar effect on plants and humans. Even so, it must be acknowledged that although the Bifidobacterium longum best spurred growth in the Lima bean plants, which I expected due to its immune response stimulation properties as well as its ability to acidify the intestine to rid of harmful bacteria, the Saccharomyces boulardii and Lactobacillus acidophilus initiated just as much growth in the Lima bean plants if we only acknowledge the tallest plant, which in each liquid group. For example, the tallest plant in each of the solution groups averaged around 76 centimeters, evidencing a consistent impact of the probiotics on the growth of Lima bean plants. Thus, the seeds that experienced no growth or lackluster growth probably failed to germinate properly, likely due to incorrect storage, aged seeds, or simply due to the fact that some seeds have higher germination rates than others, not because of the addition of the probiotics. But comparing the tallest plants in each group, we can definitely conclude that the plants watered with probiotics experience much greater growth than the plants watered solely with water. These results are extremely beneficial to plant growers worldwide because it introduces the usefulness of probiotics in plants and provides evidence for increased plant growth with the use of probiotic solutions. With these results in mind, I, in the field of botany, will continue my development of an organic probiotic-based fertilizer that will not only spur the growth, development, and natural processes of plants, but will infuse the plants with a plethora of essential probiotics and vitamins. Not only will these plants be the face of change for society, but they will also be healthier, cheaper, and larger than any other plant on the market. Additionally, using the results of this experiment, botanists, including myself, can continue discovering environmentally friendly botanical and farming techniques and fertilizers. It must still be acknowledged that one limitation in my experiment is that I had to predict the final measurement of one of the plants in the Bifidobacterium longum group because that plant was damaged before I could take its final measurement at day 28. Also, if I were to redo the experiment in the future, I would ensure to completely dissolve the Lactobacillus acidophilus tablets in the water when I watered the plants to avoid a buildup of Lactobacillus acidophilus residue on top of the soil. But all in all, the bacteria-ridding and protective properties of the probiotics, specifically the Bifidobacterium longum, positively impacted the growth of Lima bean plants and proved to be much more beneficial to the plants and their biological processes than water. This project has greatly helped me expand my knowledge of the use of probiotics in plants, and I really hope probiotics can become the main ingredient used in organic fertilizers. Thank you for your time.